The anesthesia machine will have a ventilator, flow meters, vaporizers, a bellows, and there are two distinct types of machines that you will see in a medical center, and we'll talk about them in the next section. All anesthesia machines will have an APL valve. APL is airway pressure limiting. They'll have some sort of rebreathing in the breathing system, which is where the soda line goes, and a scavenging system, which is what takes the waste gas away. Here's what shows the high, the intermediate, and the low pressure systems of the anesthesia machine. The high pressure system is comprised of the E cylinders, and they're hooked to a yoke, which goes to a step-down regulator, which regulates the pressure from each tank so that it can be used by the anesthesia machine, and that is regulated between 45 and 55 psi.
That's for the low pressure, right?
No, the high pressure system is your E cylinders.
But the low pressures, that's the 45 to 55, right?
That would be your intermediate pressure system.
Oh, okay.
Okay? Because it's regulated within an anesthesia machine even lower. And that's so the anesthesia machine can maintain a steady state. Here's a typical chart that shows when your E cylinders are filled. The one that's going to be the lowest pressure is the nitrous oxide, and that is the only gas that comes in liquid form.
So that's why it's so heavy.
That is why it is so heavy. This shows the hanger yoke on the back of the machine. And what I want you to remember is the pin index safety system. Each valve on each gas has pins in it that are indexed for that gas. Should you be missing a pin on the back of the anesthesia machine, there's a possibility that you could fit a gas that does not belong there. So that's one of the things that we look for when we service a machine. We drop the E cylinders off the machine and make sure that the pin index safety system is intact. Like I spoke of before, this is connected to a pressure reducing device, which is a regulator. Quick and dirty, it is a regulator. And it also is hooked up with a check valve that prevents the gas from bleeding back out of the system. All right, this is something that a lot of clinicians don't realize, that these cylinders on the back of the machine are there for emergency purposes. They should be checked to see that they are full, but then they should be closed so that you have tank pressure if you need it. You can run an anesthesia machine on E cylinders. There's nothing wrong with that, but that was primarily put there as an emergency backup should the pipeline systems fail. Oxygen pressure failure devices. This can be lights and alarms, or what I used to call the 5 o'clock whistle on the old Omega machines. We called it the 5 o'clock whistle because it would activate when you would turn a machine off. It would bleed the pressure, and it makes this high whistle sound for about 35 seconds. It was like quitting time. There are limitations to this. It does not prevent the delivery of a hypoxic mixture to the patient. Nothing on this machine replaces the clinician. It's merely a tool. Just cover that. The oxygen flush valve. Each anesthesia machine does have a flush. And there is a resistor in there that keeps it from going above 75 liters per minute. And this is something that they use routinely to fill the system up with oxygen. But you wouldn't want to ventilate a patient with this because it could actually cause harm, barotrauma. This is what I was talking about, the second stage. This is the actual low pressure system in the anesthesia machine. There's high pressure, intermediate. Intermediate is what the pipeline pressure that's coming into it. And then the second stage reducing device will take it from anywhere from 26 to 14 PSI. And the reason it does that is that you have 45 to 55 going in the machine. This allows for a steady state delivery with variances in pressure into the machine. The low pressure system is comprised of the flow meters, which nowadays with the digital dial-in flow meters can be a total flow meter plus the digital flow meters, the vaporizer mounting manifold, which is where the fresh gas goes through. There are check valves in line to keep the gas from passing backwards through the system if the gas is lost, and a common gas outlet. The common gas outlet can be in different places on each machine. Let's talk a minute about vaporizers. Machines will have slots for 1 to 3 vaporizers on them, and the concentration of the vapor is determined by the flow that's put into it and the dial setting. At low flow, it'll take a vaporizer a longer time to deliver the concentration than it does at high flow. There's only one vaporizer on the market that requires it be heated to be delivered, and that's desflurane. The other 2 vapors that are commonly used vaporize at room temperature and with flow. This shows how the gases go through a vaporizer. I got a better slide than this that we'll talk about. Again, to reiterate, the factors that influence the vaporizer's concentration is the flow rate, temperature, and they say back pressure. And there's check valves that prevent back pressure into the vaporizer itself. But it's the dial setting that it regulates how much flow goes through the vaporizer, so how much vapor it picks up. This talks about the circuit, and when you hear the word the circuit, circle system, that relates to that patient tubing as it is attached to the breathing system and the pathway of the gas through the breathing system. You notice over here it says fresh gas in, and then inhalation check valve. That's those little domes with the little flapper valves inside of them. Inspiratory limb is that corrugated tubing with the gas going out to the patient. There's the Y piece here, that this is where you would connect your sample line for monitoring. And the expiratory limb, and there's a check valve here with the gas routed differently through it. So while the inhalation valve is open, the expiratory valve is closed. So that's an expiratory check valve. Then it shows it going back through the CO2 canister, so that CO2 is scrubbed out of the exhaled breath. And part of that, mixed with fresh gas, is delivered back to the patient. And the reason that we do this is to save money on agent. There are times when you will not use a rebreathing device in anesthesia, and it generally involves anesthesia with small children, because they want to know that there's a set amount of gas going in them, and it's always fresh. Circle system, again, when you hear this, that means that it's the whole entire breathing system with the patient tubing. And some of the disadvantages of this is there is a potential for malfunction. If there's going to be a leak in the machine during a case, it's generally potent to these disposables, the bag or the actual patient circuit. Could be the sample line also. And with the smaller diameter tubing, it could cause resistance Also with an artificial nose and HME, heat moisture exchanger, there is an increase in pressure that is required to deliver gas to a patient. The APL, common term for this is pop-off, airway pressure limiting. This is for manual ventilation only. When you'll also hear them say bag, which is a noun and a verb in anesthesia. It's also the name of the breathing reservoir, and bagging is what they're doing to manually ventilate a patient. Again, this is talking about that this is for mechanical ventilation. This is probably one of the least serviced and one of the most important systems on an anesthesia machine, because this is what's removing the waste gas that patients exhale breath and the anesthetic agents that he's exhaling and taking them out of the room so that the operating personnel doesn't breathe it in. I find a lot of times that these systems aren't serviced on a regular basis and can malfunction. There are two distinct types of scavenging systems. There are active and there are passive. These are two examples here of active scavenging because it's hooked up to the waste gas disposal system of the facility. This one has a reservoir bag here where the exhaled breath is collected and then the suction takes it away at a known rate. There will also be another type of a pop-off valve, a mushroom valve, that if this bag gets overpressured, it opens up and it vents it to the room to prevent gas from backing up into the system. This is called an open reservoir scavenger right here. This is on the Draeger machines. There's old style open reservoir scavengers and there's the new style ones. The new style ones are much quieter. What happens is the gas is injected to the bottom of this open reservoir. Room air is entrained with it, and it's hooked to the waste gas disposal system where it's sucked back up this tube and sent back out to the waste gas disposal system. You turn this off, gas is still going into it, and you'll start to smell aging after a while during a case. The old style open reservoir scavengers made a horrible hissing noise that would drive people crazy. And they would be tempted to turn them off, and then you get a call in biomeds telling, there's a leaking vaporizer up here. We smell agent through the whole room. And we're going to cover this in the next section. Here on the anesthesia machine, there should be a card attached, and it should say how the preoperative checks are to be done on an anesthesia machine, and it should include these 8 categories. Where is the emergency ventilation equipment, which is the amble bag or a jet vent? What to do in case of a high pressure system failure? What to do with the low pressure system failure? Making sure that the scavenging system's turned on. Checking the breathing system for leaks.